Hello everybody and welcome to your video notes on Learning Target 8.4, 8.5, whatever. But this one's all about combination circuits, okay? Now, I've got an example of a combination circuit over here. And you can tell it doesn't really look like it's series or parallel, but if you break it down, it might look like there are parts that individually look like they're in series or parallel. And that's exactly what the case is. So a combination circuit is not a series circuit or a parallel circuit. It's more complex than either one. And really it's both different circuits that are kind of put together. So in order to figure out how to solve these, we have to simplify them. You have to find two or more resistors that are just in series or just in parallel. Like, hey, how about these two right here? These two are just in series with each other because they're right next to each other. The way that you could tell if something's in parallel is if you have to break a junction, or find a junction point here and the paths split. So here the paths split and we can see that, oh, okay, so these guys are in parallel, but these guys are in series, okay? So we just have to look at the ones that are only in series or only in parallel. These guys are not only in parallel, okay? Because this guy's in parallel with these two, but these two are in series just with each other. I'll explain more here in just a little bit. So find two. So we're going to start with these guys right here. And then we're going to redraw the circuit, replacing those two or more resistors with one equivalent resistor. So remember, if resistors are in series with each other, we just have to add those together. So really, this is like one resistor that is 10 ohms, if we would combine it. And then we're going to repeat until there's just one resistor left. Okay, so I'm going to show you what I mean with this circuit right here, and then we'll go over a few more examples. Okay, so here we've got our circuit. And we can easily see, so just like I was talking about before, I kept the rules over here off on the left, just for you, but we're going to start with two or more resistors that are just in series or just in parallel with each other, okay? So I told you that we were going to start with these guys, okay? Because we know that since they're in series, we're just going to add them up. And then keep in mind that a parallel circuit is, you're going to do 1 over RP equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on. So the parallel ones, when we get there, it's going to take a little bit more, but we can totally do it still. Okay? So these guys are like just one resistor that is 10 ohms. 5 ohms. This is 5 ohms. This is 10 ohms. Okay? And I want to redraw that to see what that circuit would look like. So I'm going to use my best drawing skills here. Battery here. And then I just combined these two into one, so then my new circuit is going to look like this. Okay, so this 5 ohm resistor is still as it is, so is this one. This guy now is 10 ohms because I just combined these into one. Okay, now we're going to look to see if there are any more that are in parallel or series with each other. And I see that these two are just two resistors that are in parallel to each other. Okay, and I can know that they're parallel because right here, that's when the path splits. And then I have two different options that the current could go down. And then over here, they come back together. And then there's this guy. If there's another resistor like over here, say, I could combine these two just by adding them together because those two would be in series. But I don't see any more that are in series with each other. So these guys are in parallel. So I'm going to combine them using this. Using that equation that I just showed. So to get the equivalent resistance out of this, you do 1 over 10 plus 1 over 5 equals 1 over RP. Okay? And then we're going to simplify these to decimals because that's going to be easier to add. So 1 over 10, that's 0.1 plus 1 over 0.2 is 1 over RP. Oops. Not 1 over. I already got rid of the 1 over. Okay. So now I've got, add these two together. So I'm left with 0.3 equals 1 over RP. And then I multiply both sides by RP, and then I divide by 0.3. So in the end, I end up doing 1 divided by 0.3. So RP equals 3.33 repeating. Okay, so now these two that I circled, we can combine those into just one simpler resistor, one equivalent resistance. Okay, so then let's redraw the circuit again. So I'm gonna have everything else the same that's outside of the circle. So 5 volts. Now this is all just going to become one resistor with an equivalent resistance. That guy's going to be the same. 5 ohms. Now this guy is going to be 3.33 ohms. Okay. So now we're again just going to find, just like over here says, we're going to simplify by finding 2 or more resistors that are just in series or just in parallel. And we're going to keep redrawing until we're down to 1. And we're getting pretty close. So here, I've got the 3.33 and I've got the 5. And I can see that they're just in series with each other. There's no splits between. So I'm just going to add them together. So we got 5 plus 3.33. That equals 8.33 ohms. So then I'm just going to have 5 volts. So I guess I should circle it. So these guys I'm combining down into 1 now. Doesn't matter where you draw the resistor. 8.33 ohms is my total equivalent resistance for the circuit. So in a practice problem, you're going to have to do something like, it'll say find the total resistance, or might say equivalent. And then find the total current. Okay, so if we were to find the total resistance, that's what we just found here, 8.33 ohms. And then finding the total current, well, we know that I equals V over R. We know that the total voltage supplied to the circuit is 5 volts. So we do 5 volts divided by 8.33 ohms. And we end up with 0.6 and then a bunch of zeros. So 0.6 amps. And that's what we get for our answer. Okay, let's go through another one. I mean, we can revisit what we did too. So when you have a combination circuit, you immediately go, oh, I need to simplify this. And the way you simplify is by finding the things that are in two or more resistors that are just in series or just in parallel. So you look at this circuit and we go, these guys are just in series, so I can combine them. And then you redraw those two resistors, or there might be if there's a third one there, that's fine. We just simplify that down to this resistor right here, the 10 ohms. And then we do we rinse and repeat. So there's nothing that's in series. So I see this is in parallel. Redraw that as 3.33. Did a little math. And then these guys are just in series, and I combine them to make 8.33. And then we use Ohm's law to find the total current. Okay, let's come over here to this guy. So we're going to say find the total resistance. You may want to pause the video and draw the circuit so that way you have that in your notes. And if that's all, then we're going to just go ahead and move on forward. So looking at this, I don't see anything that is in series because there are no resistors that are next to each other without there being a split. So both R1 and R2, those ones look like they're in parallel with each other because they're on both sides of a split. And then R3 and R4, those ones are in parallel with each other as well. So let's just start with the first two that I see. So we're going to combine those. So in order to combine those, I'm going to do 1 over Rp equals 1 over 100 plus 1 over 250. I'm left with 0.01 here and 1 over 250. That's something. I get 0.004. Then I'm going to add those two together. 0.0104, 1 over Rp. And then I'm going to multiply both sides by Rp and then divide by this number. And so in the end, I end up with 1 divided by 0.0104. With 96.15 ohms. So then I'm going to redraw my circuit. So I've got my 24 volts. That doesn't change. And then over here, this whole thing that I circled, that all is the same thing as one resistor that's 96.15 ohms. Then I still have R3 and R4. Okay, and this one is 200 ohms. And this one is 350 ohms. Okay, so I simplified that first one, and now I believe it's time to simplify the second one, because these two are just in parallel with each other. So I'm going to say 1 over Rp. And again, the hard part might be identifying which ones to do. But the reason why I know that these ones need to go next is because they're just in parallel with each other. There's nothing else that's in series. Like 96 isn't in series with 350 because there's a split right there. And there's nothing else that's right next to each other. So then we have to look, okay, which ones maybe are connected via a loop like this. 1 over 350. This 1 over 200. And so in left with 0.005 here. 0.0025 root 28. and some other decimals, but I'm just going to leave it there. So I'm going to combine these two. I'm left with 0.007857. Oops, I already have that written. Alrighty. So now we're going to simplify this, and we do all the fancy stuff, but really all we're doing is 1 divided by 0.007857. So RP then is just 127.27, it looks like, ohms. So, redrawing this now. So I did all of this. Those, so these two that I circled, now it's going to look like this. It's going to make it a little bit more tight here. This is my 96.15 ohms. Oh boy, look at that. That looks so much better. 127.27. Look at how much more simple that is now. We started over here with all that craziness. Simplified one, simplified the other. Now it's just 2 resistors. That's not so bad to take care of, right? We know that that's pretty, this one's easy, right? We're just gonna add those two together. In series. Okay. I'm left with 24 volts. Just the one resistor. This is the total resistance, and then to find the total current, we're going to do I equals V over R. 24 volts divided by 223.4 ohms. 0.107. All right, that's what I got here. If you want to do one more example, you can continue listening, but if you feel like you're good, go ahead and end now. So I'm just going to have one more practice problem for you to do next, if you'd like. So here you go. Go ahead and pause the video. I'm just gonna flash the answer on the screen because this video is running a little long. And yeah, so go ahead and pause, see what you can do, and I'll tell you what the answer is here in just a moment. Okay, so here's what I got for my answers. I got a total resistance of 60 ohms, and I got a total current of 2 amps. And I'll go over quickly how I got that, in case you're curious. So the first thing I started off with was combining R3 and R4 because I noticed that these two are in series with each other. This one's a little bit trickier to see because it's not so cleanly laid out. But if you just kind of follow the path starting at the battery, you go through this resistor, and then there's a split. So there's nothing in series with this right away. So there's a split that goes through this resistor before there's the next junction point. Little dots here. And then after I go through this junction, I notice that I hit these two guys before coming back to this junction point. So I know I can combine these two because they're in series with each other. Okay? And then I come back over here and there's nothing else going on there. So I start with these two, add them together, 5 plus 15 gives me 20. So these two together equal 20 ohms. Okay, these two would be 20. So it's like this one and this one kind of just loop together. So I'm left with those two that become this. Everything else is the same though, outside of that circle. And then I circled these two to add together or not to add, but to combine, because they're in parallel, because they split. And during the split, I just go through each of these. So I'm able to put them together using the parallel equation. Do all that fancy math. I end up with 15 ohms. So these two together become 15 ohms. The 25 and 20 though stay the same. See that they stay the same. And I just got rid of the parallel circuits and replaced them with their equivalent resistance. And then lastly, I can see that these are all just in a line now. So then I just add them together. I get my total resistance of 60 ohms. And so my total resistance is 60 ohms. And I use Ohm's law to find the last one. Thanks for listening. I know this one ran a little bit long, but that's all I got.